Alright guys, welcome back. In today's question, we have these two forces that are applying to the construction bracket as shown. We need to determine the angle theta, which makes the resultant of these two forces vertical. And we need to determine the magnitude of the resultant. So as we can see, these two forces have both x and y component. And since they are only in xy plane, there is no z component. What we knew from the question is that the resultant at the end has to only have j component, which means there wouldn't be any x for the resultant. So if we look at the two forces that we have in here, we have the x component of the F1. Let's call it F1x. We also have the x component of the F2. Let's call it F2x. Let's find each of these two. At the end of the day, we have to have F1x plus F2x equals 0. And let's see what we have for F1x. So for F1x, we have simply F1 times, which is 800 times cosine of 70 degrees. And for F2, we are in the opposite direction of x, so we'll have a negative sign, and it will be 425 times cosine of theta equals 0. And from here we can find cosine of theta, which will be 800 times cosine of 70 degrees divided by 425 pounds. If we calculate this, we'll get 0.64, and from the cosine reverse of theta 0.64 we get theta 49.9 degrees. So that was the first part of the question, that we needed to find the angle theta, and in the second part we have to find the magnitude of r. So we'll have ry for our rx and ry, and for ry we have this time both of the forces are in the opposite direction of y, so we'll have minus 800 times sine of 70 degrees minus the y component of f2, which will be 425 times sine of theta, which we know is 49 point. And if we calculate this, we'll get minus 1076.9 pounds. And for finding the resultant, we simply have square root of rx squared plus ry squared, which will be